For today's video, we're going to have a brief overview of equations in two variables. And so, traditionally, what we've been dealing with before has been equations in one variable. For example, 3x plus 4 is equal to 6. This is equation in one variable. But now we're going to deal with an equation in two variables. So we're going to introduce another variable. In this case, it'll be y. So an equation in two variables, an example of that would be 5x plus 2y, and I will use orange for it, is now equal to 10. Okay, that's what an equation in two variables will look like. I'm going to give you some brief definitions in this video, and then we're going to go over some example problems in the next video. And so we need to understand a few major forms and a few main topics about an equation in two variables. The first thing is we need to understand the standard form of a linear equation in two variables. So the standard form looks something like this, where we're going to have ax plus by is now equal to c, where a, b, and c are all real numbers, so they all exist in the real number set. Okay, this is known as the standard form of a linear equation in two variables. Okay, there's also a more common form called slope-intercept form, which we'll be using quite a bit, and you're probably going to be using quite a bit in your class. And so the slope-intercept form will look something like this. Slope-intercept form, and we have y is equal to mx plus b. Okay, and so slope-intercept form has two main components. The first component here is m. M, in this case, is the slope of the line we are dealing with, and then b is the y-intercept. Okay. So if I was to do a very crude drawing, and I'm going to try and not draw too much because I'm not very good at drawing, but if I was to have a very crude drawing of an xy plane, here's my x's, here's my y's, and let's just say I have an equation that looks something like this. M is my rate of change, so my change in y over my change in x, which is this portion, that would be m, and then my y-intercept is located right here, where my line, my red line, crosses my y-axis. Okay. To put things in a bit more formal terms, m, our slope, so the slope m is equal to the change in y, or the delta y, over the delta of x, the change in x. You don't need to worry too much about this. This is actually a Greek symbol for delta. It's basically a triangle. But what you need to worry about is that it's basically the difference in y between y2 and y1, where we pick two arbitrary points, and we have x2 minus x1, where we have 2 points on our line, and that would be x1 comma y1 and x2 comma y2. Okay, they have to be on our line specifically. So if I was to go back up to the very crude drawing that I wrote here, we could have one point here and another point here, and using that information we could find the slope. Additionally, we could use the two little points inside here, which would be the easiest because they cross the origin, which is 0, 0. Okay. Now we have one last main equation that we're going to work with, which is known as point-slope form. And so point-slope form is basically the equation of a line where it just passes through one point. And so it looks like this. Let's go with y minus y1 is equal to m x minus x1. Okay, where we have 1 point x1, y1. Okay. Right, and then m is obviously the slope, and m is equal to the slope. We'll have more examples of this in the next video, but this is where we'll end it today. We don't traditionally use point-slope form too much. We mainly refer to slope-intercept form as the most useful, but occasionally your textbooks and your teachers may want you to use point-slope form, so we'll cover it briefly. But there we are.